Now, we come to the mathematical economics and statistics again, that is, mathematical economics, as I told you just now, uh, represent the economic theory in the form of symbol, in the form of equations, and instead of words. Both economic theory and mathematical economics represent an exact and deterministic relationship. In mathematics, we know that the relationship expressed is deterministic. But in social sciences, we know that there is no scope for deterministic relationship. Deterministic means exact relationship. That is, suppose what I mean by exact relationship, let me write it here. Deterministic relationship means if we substitute here the value of y, we will have corresponding value of c. So, for one value of y, there will be only one value of c. But if it is just like I'll explain with the help of an example. Suppose you conduct a survey and you find out y as equal to 1000. Now, the consumption of one person is 500. Now, does it means that all those people who have income as 1000, their consumption should necessarily be 500? Not at all. There may be some person whose consumption may be 400, even though their income is 1000. There may be some persons whose consumption may be 700, even though their income is 1000. So, with the same income, we may have different people having different level of consumption. So, with one value of y, several values of c may be associated. So, it means the relationship between c and y is not exact and deterministic. But in mathematics, we talk about exact and deterministic relationship. That is, for one value of y, there should be only one value of c. Now, this exact relationship or deterministic relationship we can have only when we are in a position of conducting a control experiment. Suppose we can make all the variables who can affect this consumption income relationship and they are constant. Then in that case, for one value of y, there will be only one value of c. That is, there is no question of having different values of c associated with one value of y. So, the relationship that we get from mathematical economics are in exact form, and we have to modify it, and by including, just like here in our case, we modified it by including a random variable which we call as disturbance term, that is u. Now, the moment we include u, then this relationship become non-deterministic. This become inexact in the sense, for one value of y, now there several values of c may be associated depending on the value of u. So, this deterministic relationship, we make it as non-deterministic, or this exact relationship we make it inexact in the because in economics is a social science, and here there is no scope for conducting control experiment, and things have to be studied as it is. Now, the important thing that these coefficients, they are not known, that is, we do not know their value, and these coefficients have to be estimated. Difference between mathematical economics, statistics, and econometrics, that we have already told you, that what is the difference between mathematical economics, statistics, and econometrics. Economic theory, we have economic theory, and this economic theory written in the language of mathematics become mathematical economics. Now, when these statistical tools, that is theoretical statistics or economic statistics, means we have told you the meaning of economic statistics and also theoretical statistics. If in the theoretical statistics, whatever tools and techniques are available, we redesign this to make them suitable for the study of an economic phenomena. And when we modify these tools and techniques to suit the problems in economics, then this becomes econometrics. That is, this is what we call as econometrics. So that's why the econometrics is usually called as combination of economic theory, statistics and mathematics. So this is what we have already told you. So we'll skip this. Now we move to another thing that is known as regression. What is regression? In the case of regression, we have a dependent variable and an independent variable. We try to find out the mean value of dependent variable associated with the independent variable. You may say that how come a variable become independent and how come a variable is treated as dependent? What we actually do in the regression, if suppose we take a graph, usually dependent variables are written on this axis, that is y, and independent variable is written here, that is x, on x axis. Independent variables is written on x axis and dependent variable is written on y axis. So these independent variables, their values are given, no change. There will be no change in the values of independent variable. We have to adjust the values of y, that is dependent variable, which can be associated with the values of the independent variable. So the independent variable, its values are not going to be determined, that its values are treated as given, and for the given values of independent variable, we try to find out the values of dependent variable. That is, we have to adjust the values of dependent variable which can be associated with independent variable. So no changes are made in the values of independent variable, rather adjustment is made and we try to find out the appropriate value of dependent variable that may be associated with independent variable. That is the reason because of which this variable is dependent and this variable is independent. That is, the independent variable affects the dependent variable, but dependent variable does not affect the independent variable. That is, we have only one way of cause and effect relationship here. For example, if you write y is a function of x, then here x is affecting y, but y does not affect x. Y does not affect x. So there is a unilateral relationship, that is x affecting y. So x here is independent variable, that its values are given, its values cannot be adjusted, cannot be changed. Now corresponding to these values of independent variable, we have to find the values of dependent variable, and that's why this variable is dependent variable and this variable is independent variable. Now this regression is carried out for estimating a relationship or for making prediction, and we find out the mean or average value of the dependent variable which can be associated with the independent variable. This is an example, and in this example we see that with this value of independent variable, there are several values of dependent that are given. Just like we told you that we gave you an example in which I told you that we have an income level 1000, and with this income level of 1000, there are several values of consumption which are associated. So with this value of independent variable, this is one value, this is another value, this is another value. The question is which of these values may be associated with this independent variable, because for one independent variable there should be only one dependent variable. That is how we can find out the true relation between independent and dependent variable. So we take the mean value of these, that is mean of these values, and that we say as associated with independent variable. So here in the population as a whole, not in the sample, what we are doing is that we are associating the mean value of dependent variable with the independent variable. You may ask, why mean variable? Then a study was conducted by Galton who gave the concept of regression. He conducted a study. He found out the height of the tall father's children and the height of short father's children. That is the children of those parents whose parents were short, and the children mean height of the children of the parents who were tall. So when he calculated the mean height of the children of tall parents, and he also calculated the mean height of short parents, he found that mean height of the children of tall parents is less than the mean height of their parents, and mean height of the children of short parent is more than the mean height of their parents. So on the basis of that, he drew an inference that data has a tendency to move to average. That is, he called it universal law of mediocrity. So it means that the average value is likely to be associated with this independent variable, that is, the average value of the dependent variable can be treated as reflecting the true relation between the dependent and independent variable. Now here average of only dependent is taken because as far as independent variables are concerned, these values are given. So adjustment we see here is only independent variable, not in the independent variable. So that is the rationale for associating the mean value of dependent variable with this independent variable. Now we have notations we have given here. The dependent variable, that this usually denoted by y, independent variable usually denoted by x. So we also call the dependent variable as regressant, and the independent variables are also known as regressor. The dependent variables are the effect variable, and the independent variables are the causal variable. That we have already told you that, for example, if you write y is a function of x, then x cause change in the y, but y does not cause change in x. So x is a causal variable and y is effect variable, that is going to be affected by this. Then the dependent variable is explained variables, and independent variable is called as explanatory variable. That is, the independent variable is explanatory variable, and it is explaining the values of dependent variable. Now, regression and correlation. These are the two important topics in statistics, and often we confuse between regression and correlation. While in the case of correlation, there is no dependent and independent variable, correlation does not talk about cause and effect relationship. That correlation doesn't tell that which variable is causing change to which variable. That if there are two variables x and y, and we have estimated correlation between x and y, we cannot say that this relationship means that x is causing change in y or y is causing change in x. Correlation simply gives the information that these two variables are related. That is the only information. Correlation doesn't talk about dependent cause and effect relationship, and consequently in correlation both variables have equal status. There is no dependent variable, there is no independent variable. But contrary to that, in regression, the status of the two variables, suppose we have a two variable model like this, that is, here we say y is a function of x, this is a two variable model. Here the status of two variables are different. X here is independent variable, y is dependent variable. So consequently in regression we talk about cause and effect relationship, while in correlation there is nothing like cause and effect relationship. Same thing is mentioned here in correlation, that is whether we find the correlation between x and y or y and x, it doesn't make any difference because both variables have equal status. But in regression, you find the if you write y as given as function of x, this meaning is different compared to another one, x as function of y. So these two are given. Here x is causing change in y, here y is causing change in x. So both are different, both are entirely different. Here x is independent, y is dependent, here y is dependent, independent variable and x is dependent variable. So the meaning completely changed in case of regression if we change the variable, because the status of here the two variable, if you have a two variable model, are different. There is one dependent and one independent variable. So such type of changes are not possible in regression as we have made in correlation. But in correlation, it doesn't matter whether we study the relation between x and y or y in x. Types of regression, we have already given you some hint that there is a simple and multiple regression, there is a linear and non-linear regression. That simple regression we have, for example, this is simple regression. This is simple regression or simple regression model. Population regression function, we can say this is simple. Multiple means, suppose we have like this, that is we have alpha plus beta 0 x plus beta 1 z plus u. So here we have more than one independent variable. The two independent variables are here x and z. There may be more than two, there may be 3 or 4 like this. So these are multiple regression model, but both are single equation model. Then in this, here we have linear relationship. The relationship may be non-linear. For example, we may say, write like this, y is equal to alpha plus beta x square. Now here the relationship between y and x is a non-linear relationship because power of this independent variable x is more than 1, that is different from 1. So this is a non-linear relationship. We may have this one also, like we can write it like this, that alpha plus square root of beta and x plus u. Now this is also a non-linear relationship, but the difference between this and this is non-linear in variable and this is non-linear in parameter. So we have the non-linear relationship again may be of two types. Non-linear in variable, this is non-linear in variable because this relationship is non-linear, it is non-linear in variable, but this one is non-linear in parameter. So these are the two types of nonlinear relationship. Now, not only we have linear and nonlinear relationship, these both are simple. Let me come to that again. Simple and multiple linear, both are, we have a single equation. Along with that, we have a simultaneous equation model. Simultaneous equation model, we have more than one equation. Here we have only one equation, whether it is a simple regression model or a multiple regression model. In both we have, whether it is a linear one or non-linear, we have a single equation. We call it as single equation model. But we may also have a simultaneous equation model where there may be more than one equation, where we have no concept of dependent and independent variable, rather we have the concept of endogenous and exogenous variable. Endogenous variables are those variables whose values are determined within the system and within the model, and exogenous variables are those variables whose values are determined outside the model. So in simultaneous equation model, the values of these variables are determined simultaneously. For example, I will give you a very simple model like this, that C is equal to alpha plus beta y plus u. We have y is equal to C plus I. Now here we see in this first equation y is an independent variable, and in the second equation y is a dependent variable. So there is no concept of dependent and independent variable here. To substitute for that, we have the concept of endogenous and exogenous variable. Here the two variables which are endogenous are c and y, and I is an exogenous variable because no equation is given here to determine the value of I. So I is an exogenous variable. Now here the values of endogenous variables are determined simultaneously. That's why we call it as simultaneous equation model. So that we have already told you, we can skip that. Linear and nonlinear regression, we have also told you that in case of linear means the linear in parameters and the regression will be a straight line. In nonlinear, we see this one, if you plot a linear regression, if you plot a linear relationship, suppose we have y here and x here, then it will be in the form of a line like this, or it may be like this. So it will be in the form of a line. But when we plot a nonlinear relationship, then it will be in the form of a curve like this, or it may be like this, or it may be like this. It is always in the form of a curve. So it may also be curvilinear, that is a curve which is almost linear but not completely linear. So we call it as curvilinear. So these are the some examples of how asset return vary with their level of market risk, measuring the long-term relationship between stock prices and dividend, constructing an optimal hedge ratio. The regression model basically describe the relationship between dependent and independent variable, and we can have any type of, on the basis of our theories, we can decide which variables should be taken as dependent and which variables should be taken as independent variable. Now we come to the finding the best fit. We can use the general equation for a straight line to get the line that is best fit. However, the equation is completely deterministic. Is this realistic? No, it is not realistic, and we have told you again already this, and because of which we use a random variable. Now we come to the stochastic term. The stochastic term, that is this is the stochastic term. Let me write you that this is the stochastic term. We use the same equation that we have been using. C is equal to alpha plus beta y plus u. We can use here t, here also t, and this one is t. That is, these variables are expressed over time. That is, we should date the variable. That is called as dating the variable. Now this u is the disturbance term or random variable. There are different type of names for this. Some people call it as disturbance term, some people call it random variable, some people call it as nuisance variable, whatever may be the name itself, but basically it is a random variable that takes its values by chance. Now this random variable is very important because it includes the influence of all other variables which are not included here, and it also consider any measurement error and specification error that we have committed. Besides that, it also follow the principle of parsimony. Principle of parsimony means that if for an observation there are several explanations, then we go by the simplest one. So this stochastic term is very important, and this makes the relationship, the mathematical relationship, inexact and non-deterministic and suitable, for studying an economic phenomena, because in economics, as I told you, economics is a social science, and consequently here things have to be studied as they are, where we cannot conduct any say control experiment, and consequently the influence of other variables, that is this stochastic term which include the influence of other variable, becomes very important. This is all from this. Thank you.